developers. Today we will be going to solve a problem from the Coding Ninjas platform, and the problem is power set. So without wasting much time, let's get started. So the problem states that we are actually given a sorted array of n, and we have to generate the power set for this given array. So what is actually a power set? So power set is nothing but it's a set of all possible subsets of the given array. And we need to return all the possible subsets of this given array. So let's understand it with an example. As you can see, the array consists of 3 elements and we need to generate the possible subsets of this given array. So what is a subset? Subset is nothing but it should be a part of the array. Like if you look at this example, 1 is a subset, 1, 2 is a subset, 1, 2, 3 is a subset, 2 is a subset, 2 and 3 is a subset. And empty array is also a part of this subset, which means if I try to write them out, all the possible subsets, this is what all the subsets would be looking. So an empty subset can be a part of this array. Element 1 is a part of this subset. 1 and 2 are also the subset of this given array. 1 and 3 can also be a subset. 1 and 2, 1, 2 and 3 can also be a subset. 2 can also be a subset. Considering 2 and 3 can also be a subset. And only 3 is also be a subset. And if you look carefully, for an array of size n, there can be around 2 to the power n possible subsets. For example, here n is actually 3 and this array consists of around 8 subsets, which is what here we can generate it. Now let's look at the approach to solve this problem. We are using a backtracking technique to solve this problem. Now what does backtracking mean? Backtracking technique is a very famous technique which states that we can choose an element or we can not choose an element. I repeat once again, if we are standing at a position or at an index, we can choose that element or we can't choose that element. So these are the 2 possible cases that we need to consider, and being at these cases, we will be solving the problem. Basically what we do is, we start traversing from the array from the 0th index element and we check whether to choose that element or not. To make you understand it better, let's draw a recursive tree. We're actually illustrating the recursive tree for this particular problem. So first we would be calling a function call with the index 0, stating that we need to start from the index 0 and it consists of a list or a vector which actually stores the elements that we have encountered till now. Now we will be applying the backtracking. So what I said, when we are at a particular element, we have 2 cases. One is I can choose it or I cannot choose it. If we are deciding to choose this element, then we would be pushing this element into our array or a list data structure. So let's insert that element. Now we have inserted this one into our into our array data structure. Once we put that element into our array data structure, we will be moving forward. Now we will be making another function call stating that go for the next element. And once this function is called, now this function will be executing it. Now this function again have 2 possibilities, that it can either choose this element or it cannot choose this element. So let's look at the case when we are actually choosing this element. If we are deciding to choose this element, then we can add it into our array data structure. So this is how I have added. And if we are not deciding to consider this element, then we would be pushing that element into our array data structure. We consider the 2 cases. Now go for this first call. Why going this first call? So the backtracking and the recursion concept states that whenever we encounter a multiple recursive calls, we need to go to the first call or the leftmost call in a recursive tree. So this is the leftmost call in a recursive tree. So that's why we are going to the left one first. As you can see, we have considered element 2. Therefore, we need to move to the next element, that is at index 2. To move that, we just need to again make a recursive call to the same function next index. So the index would be 2. Now this function again have two possibilities. That is, either it can choose an element, either it can choose a second index element, or it cannot choose that element. If you are deciding to choose that element, then we are adding that element. So the element is 3. So we are adding that element into our data structure. If you are deciding not to consider it, then our array would be same without adding that element. Once we have decided to choose or not choose this element, we would be moving to the next index. That is 3. Now this function will have two possibilities. But if you look here in this array, the array is traversed completely and we are left with no elements. Since we are left with no elements, what I can do is I can put this array into my result vector. So, which means this can be my possible array. Once it has put this into the result data structure, this will go back. This will return back stating that I have done my task. Once this function call is executed, that is left function call is executed, it's time to execute the rightmost function. This function will again have two possibilities, that it can consider or it cannot consider. But if you look at the index is actually crossing the size of the array. That is, we are left with no elements. Since we are left with no elements, I will be pushing this array into my result data structure. This is my result data structure, which will store all the possible subsets. So let's push this thing also. So these are the two possible subsets that we have encountered till now. So once this function call is executed, the function will go back. And once the function call is completely executed, as you can see, the left subfunction of this call as well as the right subfunction of this call has returned me something. So this will also return back stating that I have done my task. Once this function gets a return value from his subfunctions, this function will now try to execute the right subfunction. Now let's go to the right subfunction. So we are at the right subfunction. That means we are at index 1, that is at 2. And what we need to do is, we can either choose this element or we cannot choose this element. If I'm deciding to choose this element, then I can push this element into my array data structure, right? If I'm not deciding it to put into my data structure, then it would be same as this one only. And once we actually decided it, we need to move to the next index. So therefore, we will be moving to the next index. So now this right subfunction. So since we are at the index 2 and we decided not to pick it, then we are moving to the next index. Let's make a function call with the index 2, stating that we need to go to the next index, that is at element 3. Now our pointer is at 3, and now we have two possibilities, that we can either decide to choose that element or we cannot choose that element. If we are trying to choose this element, that is this 3, then our array data structure will have 1 and 3. And if we decided not to choose this element, then our data structure would be remain same. Now we have decided the element at index 2. Since deciding factor is done, we need to move to the next element, which means we need to move to the third index. Now both the functions will move to the index 3. So the left subfunction will execute first. Since we are actually left with no array elements, I can simply put this into my result data structure. stating that this can be one of my possible subsets. So now let's add here. So now we have added 1 and 3 as a part of our subset. And once we have added, we will be returning back. Let me change the color. Since this function has returned, this will again return back to its parent function. Once this parent function receives a return from its one of the left subchild, then it will execute the right subfunction. And coming to the right subfunction, you can see that we are standing at an index where there exist no elements. That means this is our possible answer. So therefore, we will be pushing this one into our result data structure, stating that it is one of the possible subset. Once we put this data structure into our result, we will be returning back. Since this function complete its execution, it will go back to its parent function, stating that I have completed my task. And now we are at this function call. And since both of the subfunctions have returned, this function will also return to its parent call, stating that I have completed my task. Now do your remaining task. Now receiving this message, our function, which is at index 0, execute the right sub function call. So in the right sub function call, what we are actually doing is we are not considering this one. So therefore, I won't be pushing that element into my data structure. Once I have decided the element, I need to move to the next index. So we are at the index 0, then we need to move to the next index. And when we move to the index 1, that is at element 2, I can decide whether I can choose this element or I can't choose this element. If I decide to choose this element, then I can push it into my data structure and I can move to the next index, that is 2. What if I decide not to choose this element? Then the array data structure would remain same, that is an empty array data structure, and we will be moving to the next index, that is 2. So now let's execute this function call. Now we are at index 2, that is we are here. And now we can decide whether to choose this element or not to choose this element. This has two possibilities again. Either I can choose this element or I cannot choose this element. If I'm deciding to choose this element, then my data structure would have an element 3 because I'm deciding to choose this. If I'm not deciding to choose this element, then this is what my array data structure have the elements. And once we have decided, again we need to move to the next index. So the left subfunction will be executed first. And since we are left with no elements in the given array, we can directly put this into our result data structure, stating that this can be our possible subset. So therefore, we are adding 2 and 3 as a possible subset. We are adding 2 and 3 as a possible subset. Let's see. Once it has pushed this into the result data structure, then it will go back to its parent function, stating that I have completed my task. Once this function returns a value from the left sub function, then it makes a call to the right sub function. And as you can see, the right sub function is now called, and when it's called, it realizes that it has left no elements in the given array. And therefore, what it does is it simply pushes this array data structure into our result array, stating that I can be a possible subset. Once I put this array data structure into my result array, this function will return back to its parent function. And once the parent function returns the value from 2 subcalls, this will return back. Once this function got a return back from each subfunction, it will now execute the other subfunction which is on to the right side. And now it will make a call to this function. And now this function have two possibilities again. That is, it can decide to choose the element that is at index 2. As you can see, the element at index 2 is 3. So we can choose element 3 or we cannot choose element 3. And if I am deciding to choose element 3, then this would be my next function call. And if I am deciding not to choose 3, this can be my function call. Now, since we have two function calls, the left function call will be executed first. The left function call will be executed first with an index 3, stating that we would be moving to the next index. Since the index 3 doesn't exist, we will be pushing this into our result data structure. And once we have pushed that elements into our data structure, we will be simply returning back to the parent function. And once this function receives one return statement from the left subcall, then it will try to execute the right subfunction. Since we decided not to pick an element, we will be keeping the data structure as it is and moving to the next index. And once I go to the next index, this function finds that we are left with no elements. So therefore, what it does is, it simply puts its data structure into this resultant array. Since this function call has no elements, this would be returning as an empty array. And once it has stored its array data structure into a result data structure, this will now go back to its parent function, stating that I have completed my task. And once this function has completed both of its function call, it will go back to its parent function. And since this function has executed its left as well as right subfunction, this will go back to its parent function. And now this parent function has completed its left sub program as well as let sub function execution. This will return back and our program gets terminated. Once this program gets terminated, we are actually left out with a data structure where we have stored all the possible subsets. We need to return this as our output. This is how we actually generating the power set using backtracking technique. And this is what a backtracking technique is, where we actually decide to pick an element or we cannot pick an element. This is how we are actually generating the power set. Now let's go back to the platform and try to understand the code. Here we are actually given a function called pvset and provided us an array called v. We need to return a vector of type int. So for that thing, we are actually declaring a data structure called result of type vector of int. So this is what we need to return. And along with this, we need a temporary data structure. So in every function call, we have some data structure, some array data structure. This is nothing but my temporary array. So we are declaring that data structure to store the elements. And once we have declared this thing, we need to make a function call from the index 0 with parameters like by passing an array as well as my result data structure, along with this a temporary array to store the elements. Now look at this function, what we are actually doing. In this function, the first statement is we need to validate whether the index that we are standing is valid or not. If you look at this tree, we are at the index 3, but it is not a valid. So we don't have index 3. So therefore we need to return. So that's how we are actually returning. So if you're going out of the array, what we actually did is push this temporary array to our result data structure. That's what we are doing. We are pushing that temporary array to our result data structure and simply returning it. Now we need to handle the remaining cases. When we are at this function, what we are actually doing? We have two options, right? We decide to choose it or we decide not to choose it. So if you are deciding it to put it, then we are pushing it into our data structure. Therefore, I am putting that current element into my temporary data structure and moving back. This is the code that will tells us to pick this element, move to the next element and make a call to the function, right? Now, there is another case where we decide not to consider this element. So to do that thing, what we will be doing is whatever the element that we have pushed into this temporary array will be removed here. So once we remove this element, this is how my temporary array would be looking, right? And once this temporary array is looking, we are calling a function stating that we don't need to consider that element, right? So this is the case for choosing that element and this is the case for not choosing element. So you have to remember these 4 lines of code whenever you are using a backtracking technique. Once the whole function gets executed, what we actually did is we just returned this result data structure. And that's what we are actually doing here. Let's try to run this program. And as you can see that all the test case has been passed. And when we try to submit it, you can see that our program has been accepted by this platform. And coming to the time complexity of this program will take a time complexity of 2 to the power n, which is nothing but an exponential. So that's all for today, guys. We'll meet in the next video. Till then, goodbye. Have a great day.